Hello friends, let's start off with miscellaneous exercise on chapter 3. So what's the first question we'll see? Prove that 2 cos pi by 13 into cos 9 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13 is equal to 0. So now in the solution part, how do we do the solution for this? We'll see. So what is the solution for this? So first we'll take the LHS. LHS is equal to cos of 2 cos pi by 13 into cos 9 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13. We have to prove that it is equal to 0. So we'll use the formula 2 cos A into cos B is equal to cos A plus B plus cos A minus B. We'll use this formula. So here you will get it as cos of pi by 13 plus 9 pi by 13 plus cos of pi by 13 minus 9 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13. So now this is equal to cos of 10 pi by 13 plus cos of, here you are getting it as minus 8 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13. So which is equal to cos 10 pi by 13. Now here you can use, that 10 pi by 13 plus cos of minus pi is nothing but, or minus theta is nothing but cos theta. So cos 8 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13. That is, since you are having cos of minus theta is equal to cos theta. So which is equal to cos of, now if you take this part, this one and this, we'll get it as cos of 13 pi minus of 3 pi by 13 plus cos of 13 pi minus 5 pi by 13. Since we are using this formula over here, that is cos of A plus B into cos of A minus B. So what are we getting over here? We are taking this LCM over here. We can write this as cos of 13 pi minus 3 pi by 13. This 10 pi we are writing it in this way. That is, so the next step here, if you are taking next, we can write cos of 10 pi as cos of 13 pi minus of 3 pi by 13 plus, now 8 pi can be written as cos of 13 pi minus of 5 pi by 13. Now here you write as it is cos of 3 pi by 13 plus cos of 5 pi by 13. Now we got still here. Now what is this equal to? We'll see. Cos of, now 13 pi by 13 is nothing but cos of pi minus 3 pi by 13 plus cos of pi minus 5 pi by 13 plus of cos of 3 pi by 13 plus cos of 5 pi by 13. Now we know that since cos of pi minus theta is equal to minus cos theta, so therefore you are having this as cos minus cos of 3 pi by 13 minus cos of 5 pi by 13 plus cos of 3 pi by 13 plus cos of 5 pi by 13. So this and this will get cancelled, this and this will get cancelled, this is equal to 0, which is equal to RHS, hence proved. So now going into the second problem, now going into the second problem, prove that sin 3x plus sin x into sin x plus cos 3x minus cos x into cos x is equal to 0. So in the solution part, we'll go into the LHS. What is the LHS? We'll see. So LHS is equal to sin 3x plus sin x into sin x plus cos 3x minus cos x into cos x. We are having this. So now here you are using the C minus D formula. So here you will get it as, it is equal to sin C plus sin D or sin A plus sin B is equal to, you are going to get it as 2 sin A plus B by 2 into cos A minus B by 2. And what is cos A minus cos B equal to? It is equal to nothing but minus 2 sin, it is sin cos A minus cos B is equal to minus 2 sin A plus B by 2 into sin A minus B by 2. So now using this formula, we'll write down what is the above. So LHS is equal to, you get it as equal to 2 sin 3x plus x by 2 into cos 3x minus x by 2 into sin x plus, here you have to write it because it's minus, so minus 2 into sin of 3x plus x by 2 into sin of 3x minus x by 2 into cos x. So now here you are getting it as equal to 2 sin 4x by 2 is nothing but 2x into sin 2x by 2 is cos 2x by 2 is cos x into sin x minus 2 into sin 4x by 2 is sin 2x into sin 2x by 2 is sin x into cos x. So now here you are having both sides the same term, so therefore here it is equal to 0, which is equal to RHS. Now going into the next problem, you are having the third problem as given as, prove that cos x plus cos y whole square plus sin x minus sin y whole square is equal to 4 cos square x plus y by 2. So now here you take, when you taking the solution part, what do we have here? We are having here LHS is equal to cos x plus cos y whole square plus sin x minus sin y whole square. So now here you have to again use that C minus D formula. So what is that? We'll see. So here you are having cos A plus cos B is equal to 2 cos A plus B by 2 into cos A minus B by 2. And then you are having sin A minus sin B is equal to 2 cos A plus B by 2 into sin A minus B by 2. So using this formula, we'll write down what is the LHS part. So LHS is equal to, it is equal to 2 cos x plus y by 2 into cos x minus y by 2 whole square plus 2 cos x plus y by 2 into sin x minus y by 2 whole square. So we are going to get it as equal to 4 cos square x plus y by 2 into cos x minus y by 2 plus 4 cos square x plus y by 2 into sin square x minus y by 2. So taking 4 cos square x plus y by 2 common on both sides, in both of them, so you're getting it as equal to 4 cos square x plus y by 2. Inside you're getting it as cos, I'm sorry, this is cos square because the whole thing, everything is getting square now, so there, that is cos square x minus y by 2 plus sin square x minus y by 2. So this part is equal to 1 since sin square theta plus cos square theta is equal to 1. So you can write this as equal to 4 cos square x plus y by 2 into 1 is equal to 4 cos square x plus y by 2, which is equal to RHS. Now going into the, so it's given in the fourth one as prove that cos x minus cos y whole square plus sin x minus sin y whole square is equal to 4 sin square x minus y by 2. So now in the same way as how we did the previous one, we'll proceed. So solution of this, here you have to remember the formulas which we are going to use over here. So what is cos A minus cos B, then what is sin A minus sin B, all those formulas we have to be thorough with. So using those formulas, how to find out the value of this RHS, we'll see. So here I am writing again the formulas. Cos A minus cos B is equal to minus 2 sin A plus B by 2 into sin A minus B by 2. And what is sin A minus sin B equal to? It is equal to 2 cos A plus B by 2 into sin A minus B by 2. So now here we are going to take it as LHS is equal to, using this formula, we are going to get it as minus 2 sin of x plus y by 2 into sin x minus y by 2 whole square plus 2 into cos x plus y by 2 into sin x minus y by 2 whole square. So which is equal to, we are going to get it as 4 sin square x plus y by 2 into sin square x minus y by 2 plus 4 cos square x plus y by 2 into sin square x minus y by 2. So here you can take out 4 sin square x plus y by 2. We can take common. Taking this common, 4 into sin square x plus y by 2 common. So you're going to get it as 4 sin square x plus y by 2 I'm sorry, we can take out x minus y by 2, not x. So sin square x minus, so taking 4 into sin square x minus y by 2 common, you're going to get it as 4 sin square x minus y by 2 into sin square x plus y by 2 plus cos square x plus y by 2, which is equal to 4 into sin square x minus y by 2 into 1, which is equal to 4 into sin square x minus y by 2, which is equal to RHS. So here prove that sin x plus sin x plus sin 3x plus sin 5x plus sin 7x is equal to 4 cos x into cos 2x into sin 4x we have to prove. So again here we will be using the same formula which we used previously, and we'll try to bring what is the right hand side, so which is equal to here sin x plus sin 3x plus sin 5x plus sin 7x, so which is equal to, using again sin a plus sin b, you can use here, we're using for 7x and x will use, because this says x 7x plus x is again 8, and then we'll use for these two. So here when we are using in this way, what do we get? Here sin a plus sin b is equal to 2 sin a plus b by 2 into cos a minus b by 2. So which is equal to, LHS is equal to 2 sin x plus 7x by 2 into cos 7x minus x by 2. Here we'll take this as 7, a as 7x, x and 2 into sin 7x plus x by 2 into cos 7x minus x by 2 plus 2 into sin 5x plus 3x by 2 into cos 5x minus 3x by 2. So here you are going to get it as equal to 2 sin 8x by 2 is nothing but sin 4x into cos of 7x minus x is 6x, so you will get here cos 3x plus 2 into sin 4x into cos x. So if you are taking out 2 sin 4x common, you are getting inside it inside as cos 3x plus cos x. So now again using here for what is cos a minus cos a plus cos b is equal to 2 cos a plus b by 2 into cos a minus b by 2. So you are going to get it as equal to 2 sin 4x into 2 into cos 3x plus x by 2 into cos 3x minus x by 2. So which is equal to 2 sin 4x into, here you will get it as 4 into cos 4x by 2 is cos 2x into cos 3x minus x by 2 is 2x by 2, which is equal to cos x. So therefore you are getting it is equal to 4 sin 4 cos x, it's written in this order, so you can write it as equal to 4 cos x into cos 2x into sin 4x, which is equal to RHS. This is the answer. So here sixth problem is prove that sin 7x plus sin 5x plus sin 9x plus sin 3x divided by cos 7x plus cos 5x plus cos 9x plus cos 3x is equal to tan 6x. Now this is taken in the correct order itself, because here you can take this as sin 7 plus 5 7 plus 5 is 12 and 9 plus 3 is also 12, and denominator also you have the same. So using all the formulas here, whatever formulas we are having, so here you can write in the solution part, you're having sin a plus sin b formula and cos a plus cos b formula. First we'll write down what are those formulas. Sin a plus sin b is equal to 2 sin a plus b by 2 into cos a minus b by 2, and for this cos a plus b plus cos b is equal to 2 cos a plus b by 2 into cos a minus b by 2. So therefore substituting here you will get it as LHS is equal to, so in the numerator you will have it as 2 sin of 7x plus 5x by 2 into cos of 7x minus 5x by 2 plus 2 sine of 9x plus 3x by 2 into cos 9x minus 3x by 2 divided by, here you will get it as 2 cos 7x plus 5x by 2 into cos of 7x minus 5x by 2 plus cos of 9x plus 2 cos 9x plus 3x by 2 into cos of 9x minus 3x by 2. So here you can write this as 2 sine of 7 plus 5 is 12, 12 by 2 is 6. So sine 6x into cos 7x minus 5x is 2x by 2. So you're getting here cos x plus 2 into 9 plus 3 is 12. So sine 6x you are getting here again into sine 9x minus 3x is cos 6x by 2 is cos 3x divided by 2 cos, again you're getting here 6x into cos x plus 2 cos 6x into cos 3x. So here what can we take out common in the numerator and in the denominator? We can take out in the numerator, we can take out numerator 2 sine 6x common is common, and in the denominator you are having 2 cos 6x is common. So therefore here you can write this as 2 sine 6x into cos x plus cos 3x divided by 2 sine, here you can take out 2 cos 6x into, in the denominator we are having cos x plus cos 3x. So we can cancel this term. So you get 2 also will get cancelled. So therefore you are getting tan sine 6x by cos 6x is tan 6x, which is equal to RHS. So here you are having prove that sine 3x plus sine 2x minus sin x is equal to 4 sin x into cos x by 2 into cos 3x by 2. So here you are having in the solution part LHS is equal to sin 3x plus sin 2x minus sin x is equal to, here you can take this formula, sin A plus sin B is equal to 2 cos A plus B by 2 into sin A minus B by 2. So here you can write this as equal to, we are going to use it for sin A minus sin B. We will be using it for sin 3x and sin x. So you will be getting this. So here you can write this as LHS is equal to, here we will be using the formula sin A minus sin B is equal to 2 cos A plus B by 2 into sin A minus B by 2. So LHS is equal to sin 3x minus sin x plus sin 2x, so which is equal to 2 cos of 3x plus x by 2 into sin of 3x minus x by 2 plus sin 2x, so which is equal to 2 cos of 4x by 2 is cos 2x into sin x plus sin 2x. So this is equal to 2 cos 2x into sin x plus, now sin 2x can be written as 2 sin x cos x, since sin 2x is equal to 2 sin x cos x. Now here you can take out 2 sin x common in both of them, so you will get it as cos 2x plus cos x. So now again you have to use what is cos of a plus cos of b, so which is equal to 2 cos a plus b by 2 into cos a minus b by 2, so which is equal to 2 sin x into cos of 2x plus x by 2 into cos of 2x minus x by 2, so which is equal to 2 sin x into, here you're having 2 cos inside, so you'll get it as 2 cos of 2x plus x by 2 is, here you'll get it as 3x by 2. So 2 cos of 3x by 2 into 2 cos x by 2, which is equal to 4 sin x into cos x by 2 into cos 3x by 2, which is equal to RHS. Going into the 8th problem, tan x is equal to minus 4 by 3, x in second quadrant or quadrant 2. So here solution part, you know that tan x is equal to minus 4 by 3 in the second quadrant, means here you are having, this is, see, x dash y dash is the first quadrant, second quadrant, third quadrant and fourth quadrant, 0 to 90, 90 to 180. So here you are having this lies between, x lies between this, that is, so here you are having x is in the second quadrant, means that is x lies between pi by 2 and pi, it lies between these two values. So now here, which implies that if you are taking by 2 all throughout, you will get it as pi by 4 is less than x by 2 is less than pi by 2. You are dividing throughout by pi by 2 here. We are finding out what is tan x by 2. So in order to find out tan x by 2, we have to do all this. So here, that is, we are getting that x by 2 lies in the first quadrant, so that all the trigonometric ratios of x by 2 are positive. Now you know that if x lies in the first quadrant 0 degrees to 90 degrees, you have seen in the previous video that all the trigonometric ratios in the first quadrant all are positive over here. You are having all silver tea cups, so which means that all means all the trigonometric ratios are positive in this case. So now we have here, we have an identity, Pythagorean identity, secant square x is equal to 1 plus tan square x, which is equal to 1 plus, now here you know that since it is tan square over here, you know tan square x is nothing but minus 4 by 3 whole square, so which is equal to 1 plus 16 by 9, which is equal to 25 by 9. So therefore you're getting secant x is equal to plus or minus 5 by 3, because it's root of 25 by 9, we are getting it as, but x is in the second quadrant, we know that. X by 2 lies in the first quadrant, but x is in the second quadrant. So therefore here in the second quadrant, all silver means sine and cosecant only are positive. So therefore here again you will get secant x is negative. Therefore you are getting here, and it is equal to, so therefore secant x is equal to minus 5 by 3, and here which implies that cos x is equal to minus 3 by 5, because here only sine and cosecant are positive, secant and cos will be negative in the second quadrant. So we also know that, sine square x by 2 is equal to 1 minus cos x by 2, since sine square theta is equal to 1 minus cos 2 theta by 2. So we can write the sine square x by 2 is equal to 1 minus cos x by 2. So in the place of theta we are taking it as x by 2. So we are getting this value. So which implies that therefore you can write this as sine of x by 2 is equal to under root of 1 minus cos x by 2, which is equal to under root of 1 minus of minus 3 by 5 by 2, which is equal to under root of 1 plus 3 by 5 by 2, which is equal to, you are getting it as 8 by 5, that is root of plus or minus, we will be taking this as it is equal to plus or minus here. So this is equal to 8 by 5 by 2. So you can write this in this way. So this will be equal to plus or minus root of 4 by 5, which is equal to plus or minus 2 root 5. So but you know that x by 2 lies in which quadrant? Lies in the first quadrant. So in the first quadrant you have sine x by 2 is positive. Therefore sine x by 2 is equal to 2 by root 5. So we also know that, cos square x by 2 is equal to 1 plus cos x by 2, since cos square theta is equal to 1 plus cos theta by 2. So here going into this, you have to find out all the trigonometric ratios. Here we are finding out. So therefore here cos of x by 2 is equal to root of plus or minus 1 plus cos x by 2, which is equal to root of plus or minus 1 plus, what is cos x we got here? Cos x is equal to, here we are having it is equal to minus 3 by 5. So substituting in this, you are going to get it as minus 3 by 5 by 2. So which is equal to plus or minus under root of 5 minus 3 by 5 into 2. So which is equal to plus or minus 2 by 5 into 2. So 2 will get cancelled, which is equal to plus or minus 1 by root 5. So cos x by 2 is equal to 1 by root 5, since x by 2 is in the first quadrant. Next we have again what is tan x by 2 is equal to, what is tan x by 2? We will get it as sin x by 2 by cos x by 2 is nothing but equal to tan x by 2. So therefore here what is sin x by 2? We got it as 2 by root 5. 2 by root 5 by 1 by root 5. So root 5 will get cancelled. The answer is 2. So therefore over here all the trigonometric ratios which we found out over here, we have to find out that we have to find here what is sin x by 2, cos x by 2 and tan x by 2 for all the problems in from 8 to 10. So we found out what is sin x by 2. Sin x by 2 is, therefore you can write down, therefore sin x by 2 is 2 by root 5 plus or minus 2 by root 5 it is. So it is positive only you will get. So it is equal to 2 by root 5. Cos x by 2 is equal to 1 by root 5 and tan x by 2 is equal to 2. So these are the answers which you got for 8th problem. So now let's go to this next problem. That is cos x is equal to minus 1 by 3, x in the quadrant 3. So in the solution part again we have to find out what is sin x by 2, cos x by 2 and tan x by 2 for this. So again we'll proceed as we did in the previous problem. Since you know that cos x is equal to minus 1 by 3 and x is in which quadrant, we'll just see, is in the, see you know that it is first, second, third and fourth, 0, 90, 180, 270 and 360. So therefore here x is in which quadrant? All silver, teacups. It is in the second quadrant, that because it is in the second quadrant, so that sin x by 2 is greater than 0. We can see here cos x by 2 is less than 0 and tan x by 2 is less than 0. So here cos x is equal to minus 1 by 3. X is in which quadrant? It is lying in third quadrant. So it's given for us. It's given that it lying in the third quadrant. X is in the third quadrant. So that is x lies between pi and 3 pi by 2. This is given to us, isn't it? So this is given to us means this is given, lies in the third quadrant. So it lies between pi and 3 pi by 2. So now we have to see where will x by 2 lie. So what are we doing is we are dividing throughout by 2. So pi by 2 is less than x by 2 is less than 3 pi by 4. So which implies that 90 degrees is less than x by 2 is less than 135 degrees. So here we can see that clearly 90 and 135, it is lying in the second quadrant. So that is x by 2 lies in the second quadrant. So in the second quadrant, when we are finding out x by 2, we'll get that it is positive because only sine and cosecant are positive in that. Sin x by 2 is greater than 0, cos x by 2 is less than 0 and tan x by 2 is less than 0. So we are having all these. So now we know that sin square x by 2 is equal to 1 minus cos x by 2. So therefore sin x by 2 is equal to plus or minus root of 1 minus cos x by 2, which is equal to plus or minus root of 1 minus of minus 1 by 3 by 2. So which is equal to plus or minus root of 3 plus 1, that is 4 by 3 by 2, which is equal to plus or minus root of 4 by 3 into 2. So we are getting it is equal to plus or minus 2 by 3. So sin x by 2, since it is in the second quadrant it is positive, therefore it is equal to root of 2 by 3 since sine x by 2 is greater than 0. Next we are having what is cos square x by 2 is equal to 1 plus cos x by 2. So therefore cos square x by 2 is equal to cos x by 2 is equal to root of plus or minus root of 1 plus cos x by 2. So therefore here you are getting it as equal to cos x by 2 is equal to root of plus or minus root of 1 minus 1 by 3 by 2. So which is equal to root of plus or minus 3 minus 1 is 2 by 3 into 2. So which is equal to minus 1 by root 3 since cos x by 2 is equal to minus 1 by root 3 since cos x by 2 is negative in the second quadrant. Now going into the third one, that is tan x by 2 is equal to sin x by 2 by cos x by 2 which is equal to root of 2 by 3 by minus 1 by root 3. So which can be written as 2 by root 3 root 2 by root 3 by minus 1 by root 3. So this will get cancelled. So the answer is minus root 2. So therefore we have sin x by 2 is equal to root of 3 by 2 by 3 root of 2 by 3, then cos x by 2 is equal to minus 1 by root 3 and tan x by 2 is equal to minus root 2. So these are the answers we are getting for this. We have sin x is equal to 1 by 4, x is in the third quadrant. So therefore you can write the solution part of this in this way. Since you know that sin x is equal to 1 by 4, x is in the second quadrant. So therefore you know that in the second quadrant, what does this mean? First, second, third and fourth. So all silver tea cups. In the second quadrant you are having sign is positive. So therefore it lies between, in the second quadrant means x lies between pi by 2 and pi, that is 90 and 180. It lies between this. So which implies that now we are going to divide it by 2. So pi by 4 is less than x by 2 is less than pi by 2. So that is x by 2 lies in the first quadrant. So here all the t ratios are positive. So therefore sin x by 2 is greater than 0, cos x by 2 is greater than 0 and tan x by 2 is also greater than 0. So all t ratios are, what are t ratios? T ratios are nothing but trigonometric ratios are positive. So therefore here you are getting now what is cos square, what sin is given. So we can write it as cos square x is equal to 1 minus sin square x which is equal to 1 minus 1 by 16 which is equal to 15 by 16, or cos x is equal to plus or minus root of 15 by 4. This is the value we got. And cos x is negative in the second quadrant. Cos x is negative in the second quadrant. Since we are given x lies in the second quadrant, so therefore you are getting cos x is equal to minus root of 15 by 4. So now we know that sin square x by 2 is equal to 1 minus cos x by 2, which implies that sin x by 2 is equal to root of 1 minus cos x by 2 which is equal to root of 1 plus root of 15 by 4 by 2. So which is equal to root of 4 plus root 15 divided by 8. So which is equal to, now multiplying throughout by in the numerator and denominator by 2, you get it as 8 plus 2 root 15 divided by 16. So which can be written as 5 plus 3 plus 2 root 5 into root 3 divided by 16 under root. So which is equal to, you can write this as square root of root 5 whole square plus root 3 whole square plus 2 root 5 into root 3 divided by 16. That is a plus b whole square formula. So this will become equal to root of 5 plus root 3 whole square divided by if you're taking here 4, we can write the bracket in this way because it's whole square. So which is equal to root 5 plus root 3 by 4. So therefore we got here cos x by 2. So sin x by 2, we got this. So now what is cos x by 2? We'll see cos x by 2 is equal to root of 1 plus cos x by 2, which is equal to root of 1 minus root 15 by 4. Only for this is by 2. We're taking this. So which is equal to 4 minus root 15 divided by 8 and denominator with 2. So you're going to get it as 8 minus 2 root 15 divided by 16. So which is equal to under root of, you can write this as root 5 whole square plus root 3 whole square, because 5 plus 3 is 8, minus 2 root 5 into root 3 divided by 4 square. So which is equal to under root of root 5 minus root 3 whole square divided by 4 square, or it can be written as under root of root 5 minus root 3 by 4 whole square. So removing the square root here, you will be getting it as equal to root of 5 minus root 3 by 4. So cos of x by 2 is equal to root 5 minus root 3 by 4. Next, tan x by 2 is equal to, therefore tan x by 2 we can write it as sin x by 2 by cos x by 2, which is equal to root 5 plus root 3 by 4 divided by root 5 minus root 3 by 4. So 4 will get cancelled. So you are getting it is equal to root 5 plus root 3 by root 5 minus root 3, which is equal to root 5 plus root 3 by root 5 minus root 3 into, rationalizing this, you get it as root 5 plus root 3 divided by root 5 plus root 3. So which is equal to root 5 plus root 3 whole square divided by 5 minus 3, which is equal to 5 plus 3 plus 2 root 5 into root 3 by divided by 2. So which is equal to 8 plus 2 root 15 divided by 2, which is equal to 4 plus root 15. So this is nothing but tan x by 2.